Alright, so in this lesson we will rewrite quadratic expressions. So rewrite quadratic expressions by factoring and providing evidence of equivalence. So provide evidence of equivalence. So we'll do the same thing we did in the last lesson as far as rewriting by factoring. But this time we're going to offer some evidence that what we have is, correct or whatever. Or, yeah. So we have this expression, negative 5x squared minus 7x minus 2. Remember, let's multiply a and c. Actually, I'm going to change this color. So let's multiply a and c. So a negative times a negative is a positive 10. I need factors of 10 that create or that combine to negative 7. So if I do 1 and 10, I get 11. If I use negative 1 and negative 10, I get negative 11. Remember both? Oh, I know. This, yeah. Oh, never mind. Okay. So a positive times a positive is a positive. And then with positive 11. A negative times a negative is a positive. But when I combine them, I get negative 11. I'm looking for this negative 7. So let's do 2 and 5. 2 and 5 will give me 10, but then they add up to positive 7. But negative 2 and negative 5 will also give me positive 10, but they create negative 7. So this is the one right here. Oops. Cool. So I need to rewrite this expression up here. I can go a little further down. Okay. And I will write negative 5x squared. And I'm going to write minus 2x from right here. Minus 5x from right here. And then I can't forget about this minus 2. Okay, let me go a little further down. Now I'm going to factor numbers out of here. Remember, I could have written negative 5x squared. Instead of this minus 2x and then minus 5x, I could have written minus 5x and then minus 2x. It doesn't matter, you get the same answer. But right now I'm going to factor a number out. So one number goes into 5 and 2. Well, there's nothing except for 1. So I'm just going to pull out a 1. And then I have 2 x's here, like x times x, and then I have an x here, so I can pull out an x. And a positive times a what is a negative. A positive times a negative is a negative. 1 times what is 5. 1 times 5 is 5. X times what is x squared. X times x. Cool. A positive times a what is a negative. A positive times a negative is a negative. Ooh, sorry, I had a hiccup. A 1 times what is 2. 1 times 2. X times no x's. We don't need anymore. Remember that I will need to copy this. Copy. And so I get negative 5x minus 2. And let's see. So what times 5 is 5? What times 2 is 2? Well, that's a 1. And we need this to be a, what times a negative will be negative? A positive. Let me just check this out. Positive times a negative is a negative. A positive times a negative is a negative. Okay. And then finally, I have 1x copies of negative 5x minus 2 and 1 copy of negative 5x minus 2. So I have 1x plus 1 copy of negative 5x minus 2. Now, most of the time they're not going to write it like that exactly. They're going to write it like x plus 1 times negative 5x minus 2. because we don't usually write that 1 in front of the x, as you know. Okay, so remember that we have this expression, which is equivalent to this expression, which is equivalent to this expression, which is equivalent to, like, well, technically that one too, but that expression, or those expressions. Actually, I will put this star right here between them. So all these expressions are equivalent, they just look different. So negative 5x squared, which is this one, minus 7x minus 2, and let's go to, well, we're interested in this one, and x plus 1 times negative 5x minus 2 are equivalent. They just look different. All right, so there's two ways of doing this. There's two ways of showing evidence or proof that they are equivalent. First thing I'm going to do is I'm going to take this bad boy right here. X plus 1. I'm going to multiply by negative 5x minus 2. So a positive times a negative is a negative. 1 times negative, 1 times 5 is 5. X times x is x squared. A positive times a negative is a negative. 1 times 2 is 2. X times no x is, there's still an x. A positive times a negative is a negative. 1 times negative 5x would be 5x. 1 times 5 is 5, right? And then a positive times a negative is a negative again. 1 times 2 is 2. And then we combine like terms, so we end up with negative 5x squared minus 7x minus 2. So you can see that they're the same. Like, this is just a different version of this. It's just written as multiplication. Now, there's another way that I can show you. So I'm going to write my original expression. I'll write that in purple. Negative 5x squared minus 7x minus 2. That should be equivalent to x plus 1 times negative 5x minus 2. Okay? So what I'm going to do is I'm going to make x something. It doesn't really matter what it is. I would stay away from 0 once again, because sometimes 0 can make things disappear and everything turns into 0 sometimes, and then you just end up with, like, I don't know. Sometimes 0 makes things look the same when they're not. So let's just be careful about that. I'm going to pick like 2. I'll use 3. Because there's a lot of 2's up in here. So this one will say negative 5 times 3 squared. I guess I could put that 3 in orange. Squared minus 7 times 3. And then minus 2. So exponents first, right? So 3 to the second power is 9, because 3 times 3 is 9. Minus 7 times 3 minus 2. So a negative times a positive is a negative 45. Negative times a positive is a negative 21 minus 2. And then I get, that's negative 65, 66. Negative 66 minus 2, which is negative 68. And we should get the same thing over here. So I'm going to write, I guess I'll set it up like this. And for x, I'm going to put 3. I don't need parentheses here, just make it look confusing. So 3 plus 1. And we get negative 5 times 3 minus 2. So order of operations, we do everything inside parentheses. So I'll do this one first. I get 4 here. But in this parentheses, I have to do that first. So negative 15 minus 2. I'm not done with this parentheses, so I bring down the 4. Negative 15 minus 2 is negative 17. And then 17 times 4. Well, 4 times 10 is 40. 4 times 7 is 28. So 40 and 20 is 60. And then, yeah, that 8, so negative 68. Always make sure, though. Always make sure. All right. And that's it. Thank you.